Hello everyone, welcome to another lecture of NumPy. And today, okay, in this lecture, we will see actually that how we are using gradient descent for minimizing our cost function. So before that, what we know the gradient descent, okay, for bit into minus xi. Okay, got it. Now let's start from a data set. Okay, suppose that we have a data set, very simple data set. Okay, we have data in which we have x and y. And what is in the axis? We have 1, 2, and in the y, we have 2 and 2.8. Okay, 2 and 2.8. This is our simple data set. Find using the gradient descent. Okay, we will find it using the gradient descent. So what we'll do here is actually is that so what we have to first do, okay, we have here is y hat beta 0 plus beta 1 x. Okay, beta 0 and beta 1 x. Now we will initialize our parameters. Okay, initialize our parameters. So for the m, it's not m, because actually I have written in my notebook or my Notion page. So I'm actually got m, but it will be not m. So what it is here actually, let's initialize with the 0 and beta 1 is actually 0. Okay, and what our hyperparameter is nothing but the alpha. Okay, hyperparameter. Okay, ignore the spelling for right now. The learning rate, nothing but the alpha 0.01. Okay, and suppose the iteration should be 10. Now what we're doing that we will use our first prediction. We will do our first prediction. So y hat 1. Okay, beta 0 plus beta 1 x. So y hat 1, what it was actually, beta 1 0, beta 0 0, it's 0 into our x 1. So what it will be, beta 1 y hat 1 0. Now we will make, okay, now we will get our error, we will get the rate of our errors. Okay, what is error here? What is our error? It is nothing but y minus y hat 1 I. Okay, so what is y1 2? Okay, it is 2. Okay, it is 2 and 2. Okay, wait, I haven't predicted for the next variable. Okay, so we'll have to predict for the next variable also. Okay, for the next video also. Then what is beta 0? Why I make this such mistakes, man? Again we will go for our x. It was actually x1. Now we will go for x2. What our x2? It was 0 plus 0 into what was our x2? 2. 2. Okay, what is it actually? 0. Now we will find for the y1 y hat 1. Okay, what is actually 0? Okay, so the error for the first is 2. Okay, and for this, what is its error actually? It was nothing 2.8, it was actually 2.8. See, it is 2.8 minus 0. What's the error is? 0 or 2.8. Okay, now we had any error? No, but we need to minimize our beta 0 and beta 1 because we initialize it to 0. Okay, now we have to minimize it to get the lowest error. Because it is 0 actually. How would you get it? Now we have to update it. Okay, now we will use our gradient descent. Okay, it's nothing but derivative of our MSE. Okay, by the derivative of our beta 1. Hat I. Okay, We'll do it. So what is here actually? Let's see. So 2n, what the n here is 2 for the sigma. What is here actually for the x1? For the x1, what is the x1? 1. Okay, and what was the first? Nothing but 2. So 1 into 2, 1 into 2 plus. Now the second iteration, it was first for the 1. It first went for the 1. Now it will go for the 2 for the second iteration. The second iteration we are going for this data. For this data is the error here. The error here is 2.8. Okay, and what was x here? Nothing but 2. Okay, so 2 into 2.8. Okay, do you have any problem? No. Let's do our quick. It will be minus 1, 2 plus it is 5.6. Okay, minus 1, 7.6, and what here we got actually is this. So this is the derivative of our beta 1. Okay, derivative of our beta 1. Got this? Now we'll find the same for the beta 0. Beta 0. Okay, what it is here? 2n. Okay, this. For the n, then we will actually go for y hat, yi minus y hat I. This, we'll do this 2. Okay, what is here actually is that we'll do 2. Okay, plus 2.8, because we don't have any parameter here like x1, xi. Okay, so we'll simply go 2 plus 2.8. Okay, now what we will do here is, minus 1. Okay, it is nothing but 4.8. It will be minus 4.8. Okay, we got this. We got the gradients of beta 0 and beta 1. Now we will update. We will update the parameters. Update the parameters. Ignore my writing right now. I need to make you understand, not to write good. So for not m man. So for the beta 1. Okay, what is it? Is beta 1 minus learning rate, which is nothing alpha. Okay, and what we have initialized our alpha into derivative of MSE with the respect to the derivative of beta 1. Okay, which is nothing but 0 minus 0.01. Okay, into minus 7.6. Okay, now what it will be? What it will be? It will be nothing but 0. Okay, so 0 will be plus. No, minus and minus, minus into minus will be plus. Now it will be 0.076, and the finally it will be 0.076. And now this is our new beta. This is our new beta 1. This, got it? And we will have to update our beta 0. What is our beta 0? Here, beta 0 minus learning rate into derivative of MSE with the respect of beta 0. Okay, beta 0. What is beta 0 here? 0, as you know, man. 0.01. What is its MSE, the derivative of it? Nothing but into minus 4.8. Okay, and what its new value will be? Plus 0.048. Okay, and it will be 0.048. And this is our new beta 0. Okay, new beta 0. So now in the first iteration we have done with our first thing, in which we have initialized our parameters to 0, 0, and we have got our new parameters, which is more than 0, which is larger than 0, bigger than 0, which is 0.076 and 0.048. Okay, we have got this. Now we have to predict on this actually. Okay, now I will do again this. Okay, now I will again do this one more iteration. I will show that how it's get updated. Okay, now again we will make our prediction. Okay, again I will make my prediction, and I have my notion ready for it. I won't be taking much time. So, new prediction. Okay, new prediction. Okay, where is beta 1x plus beta 0? So our beta 1 x will be 0.076 into what was our x1? What was our x? Okay, into 1 plus 0.048. Okay, what will be? It will be 0.124 for this. Okay, for this. This is actually the new one. Now y had 2. Okay, again, what it will be? Again for the next beta 1, 0.076 into 2 plus 0.048, which will be nothing but 0.2. Okay, now we will perform the gradient descent in it again. The new batch, and we have to perform the gradient descent here also. Okay, so we'll do the gradients. Okay, for the beta 1, the MSE with respect to beta 1. Okay, which will nothing this and xi into this. Okay, by 2 1 into 1876 plus this point. Okay, this point 2 into 2.6. Okay, we're just performing all this. Why? Because see, we have to do this actually here. Actually, now this will be actually, if you do it, then minus 1 1.786 plus 52. Okay, 76 this and I will this actually what I'm thinking that I will show you my the page where I got the data from. Okay, I use chat gpt. Actually, I'm like copy pasting from the chat gpt, so I will give you the in the screens of chat gpt that how it is actually improving, updating and all this thing. It has actually 4 to 5 iterations. And see, this is how we actually do it. This is what actually happens in behind the formula. Okay, and we have to get this in mind. Okay, and we have to get this in our mind that this is how it actually uh, happens. Okay, and this is what I actually want to tell you all, that this is how it works. Okay, so I will actually give you the data. So first I actually think that you would have got the idea that how it actually happens. Okay, because I have shown you with the first example. Okay, the first iteration, the first I shown it was actually the first iteration. Now it will happen with the second, third and fourth time. Okay, so I'm thinking that you would have actually got the idea of how do we actually do it behind the gradient descent. Okay, behind the gradient descent, and this is what actually happens in behind the gradient descent. Seeing that we got the error. Okay, we find the derivatives of it and then we update it. Okay, and what is here actually the learning rate? Okay, see, learning rate is actually a hyperparameter. Okay, which if we change, then the result will get changed. Okay, so if what do you think that if we would have used 1 instead of 0.01. Okay, 0.01, then our answer would be very different. Our answer would have been very different, because it actually changes the whole the whole derivative and update the new betas. So changing the hyperparameters can actually affect our new parameters, which is beta 0 and beta 1, and it can actually affect our prediction. So it is actually very important to get a very suitable hyperparameter for making prediction. Okay, so that was it for this lecture, guys, and I hope that you would have really enjoyed it. And if you do, then okay, share with your friends and actually tell that which was your favorite part. Actually, was it the math and all. Okay, so thanks for watching till now, right now, guys, and I hope that you would have enjoyed. So thanks for watching till right now. Bye bye.